Hello students, today in your algebra class we're going to be working on solving systems of equations graphically. Now just as a quick refresher, let's look at a couple quick warm-up problems. In this instance, all we're being asked is to graph each equation. So using slope-intercept form, which is y equals mx plus b, we're going to start with 1, determining what the slope and the y-intercept is. So in this case the slope is 2, the y-intercept is negative 3. Next thing we're going to do is we are going to graph or plot the y-intercept, and in this case the y-intercept is at negative 3, so we're going to go to the y-axis and go down the 3, so 1, 2, and 3. After we've plotted the y-intercept, we're going to use the slope to plot the next point. In this instance the slope is 2, or 2 divided by 1, therefore we're going to rise 2, 1, 2, and we're going to run 1. And plot the second point. From there, the rest is simple. We're just going to connect the two dots with a line and not a line segment. And we've gotten our graph. Now, the purpose is that at the end of this lesson, you should be able to solve equations or solve systems of equations graphically. So to give us a summary of what our possible options would be for our solutions, we have 1, different slopes. If the slopes are different, then they're going to have a point of intersection. The point of intersection in this instance is right here. Okay. Now what this means is that this is the point where the two lines intersect, and this is where their solution is. This is the point where they'd both be exactly the same. In this instance, where they have the same slope but different y-intercepts, this essentially means, based on the graph, means that they never touch. And if they never touch, then there is no point of intersection, which means that there are no solutions. So no touching means no solutions. Now in this instance, the last case, it says same slope, same y-intercept, which means that these two lines are exactly on top of one another. So if we're basing the number of solutions on the number of times they touch, we can see on the first one they touch once, therefore there is one solution. On the second one they touched 0 times, which means there are 0 solutions. In this last case, they're touching in every single point, which means there are infinitely many solutions. Okay, so touching once means 1 solution, touching twice means 0 solutions, and touching at every single point means touching infinitely many times or infinitely many solutions. Now, the point of their intersection is where their solution lies. So let's practice a couple. Before we get started, they give us a few basic problems. It says, is the point negative 1, 5 a solution to the given system of equations? Well, to check this, all we're going to do is we're going to substitute our values for x and y into the two equations that they gave us and see if it works. If it works for both, then it's a solution. If it works for one or none, then it is not a solution. Okay, so just a note, and you probably want to write that down. Must solutions tested must work for all equations. Okay, so let's try. For the first one, it says x plus y equals 4, and because the point we have has a x value of negative 1 and a y has 5, we're going to see if that's equal to 4. So negative 1 plus 5 is 4, and that's equal to 4. Therefore, this is a solution, or this is true. The second one says x is equal to negative 1. Well, we're going to substitute our value for x because that's the only one we have, so x is negative 1. That's equal to negative 1. So this is also true. Now because this works, or because it's true for both solutions, then we could say that negative 1, 5 is a solution. Now, example 2 says they want us to graph each equation and then find their solution. So, first thing for every single graphing problem is to determine what the m and the b are, the slope and the y-intercept. So for the top equation, m is equal to 1 because there's 1x, and b equals 2. For the second one, the m is equal to negative 2, and the b is equal to 2. So, to make this easier, I'm going to change the color of the top one to blue, or to red, and the bottom one to blue. In this instance, we're able to determine each graph based on their color to make it slightly easier. So, we're going to do the one in red first. The red, we first graph the y-intercept, which is at 2, so 1, 2. Next thing we do is we use the slope to plot the next point. And since the slope in red is 1, because it says it here is 1, the rise over run is 1 and 1, so we rise 1, we run 1. Okay, next thing we're going to do is we're going to graph our line. So when we graph our line, it should look like so. Now we're going to do blue. Blue, the y-intercept is also at 2. And the slope is negative 2. That means rise negative 2, so down 2 and run 1. And once again, we're going to draw our line. Now, the question is, where is the solution? Now, in this instance, it's just asking us where do they both intersect. And if we're paying attention, the solution is quite simple. It's right here where I'm showing you with the black arrow. And that point is 0, 2. Now the solution is now at 0, 2. That means at the point 0, 2, this is where both lines intersect. I'm going to try one more problem. It says, suppose you have $55 in your bank account. So what might make doing problems like this easier is for us to underline the important words. And usually, because this is a math class, we want to look at the numbers. So $55 in your bank account. You start saving $10 each week. And usually when they mention each week or each something, it's usually our rate. Usually the number that's attached to the variable. Now, then the next thing it mentions is your friend. Your friend has $20 in her account and saves $15 each week. When will your friend have the same amount of money as you? So same amount of money means when do they intersect? So we're going to write an equation for you. Then we're going to write an equation for your friend. Now, we're going to let y be equal to the amount of money in your bank account. So y equals the amount of money in your bank account. So y equals, now you start off with $55 and you add $10 each week. So we're going to say x is equal to the number of weeks. So, for your equation, you have y equals 55 plus 10x, or to make it look a little cleaner, we write y equals 10x plus 55. Now your friend, y's number in their bank account. Now they have $20 in their account, but they put in $15 each week. So this is the equation for them, or we're going to write it in y equals mx plus b form a little bit nicer. Now, to make this easier, again, it's always the same thing. We're going to start with m equals 10 and b equals 55. Next thing we're going to do is find out what the m and b are for the second equation. So this would be 15 and the b would be 20. So, next thing we're going to do is graph it. So, let's try this. So we're going to look at a graph that I had already made of the scenario that we have. And in here you could tell that they intersect right at this point here. And that point just happens to be 7 and $125. Now the 7 represents our x, and if you look at what we wrote down earlier, x is equal to the number of weeks, and y represents the amount of money. So in this case, this is saying that in 7 weeks, they will have the same amount, and that same amount will be $125. So going back to the question, it says when will you and your friend have the same amount of money in your bank accounts? So when as in like a date. So you could respond back and say that in 7 weeks we will have the same amount. Okay, so that's how we interpret the data. Now it's your turn. I want you to do 2 very simple problems where you're going to just graph each one and graph your solution. Solve it and determine the solution by graphing. Then you'll post it in Modo. First person will start, everyone else will just reply. That's all for now. See you guys next time.